this video, we're going to be graphing rational functions, all right? And we're going to do 3 of them, and that's going to be these 3 here, okay? This one, and then this one over here. And when you graph rational functions, what you really are looking for is kind of like the degree of both the top and the bottom. That's going to be kind of pivotal to how you end up graphing these things. You notice on each of these, we have sort of one of each different type. One where the degree on the top is a 2, and the degree on the bottom is also a 2. So this one, it's equal, you might say. This one, the bottom degree is bigger. This one, the top degree is bigger. And in each of those different cases, that's going to really play into kind of how we deal with a horizontal asymptote, right? The rest of them, though, we're going to find these different parts. We have the x-intercepts, the vertical asymptotes, the horizontal asymptotes like I was talking about, and then if there's a slant asymptote, as well as the domain of each. So let's start with that first one, and then we'll get to the other 2 in a second. I also need to draw a graph up here. Let's get going. All right, so we're gonna start with this first one here, and the first thing it wants us to find are the x-intercepts. All right, to find the x-intercepts of a rational function, what you want to do is find the zeros of your numerator, the zeros of the top. And so if I were to set this equal to 0, just the top part here, I would obviously have to factor this and then set the 2 factors equal to 0 and solve. So let me do that really quick for you. All right, so I found my 2 x-intercepts here to be -5/2, which is back at -2.5 on my graph, as well as x equals 4. So again, this is where they're going to cross my x-axis. In fact, I might want to list this out as well. Your teacher probably wants you to do that. -5/2 and x equals 4. Okay, so the graph has to do something where it crosses here and crosses there. We don't quite know what the rest of it looks like yet, so we have to find our other parts. Okay, the vertical asymptotes, this is going to be where we have the zeros of our denominator. And if you recognize the bottom at all here, this is a difference of squares. If I were to add 9 over, take the square root of both sides, I would get plus or minus 3. Right, so I get the lines x equals plus or minus 3. And at -3, we're going to have a vertical asymptote. So this is just a line that goes straight up and down. Same thing at +3 over here. So this gives us a little bit of an idea of what's happening. In the middle here, it has to cross at 2.5 and be probably stuck inside those 2 vertical lines. And over on the right side, our graph is going to do something where it crosses the x-axis there, and then it's either going to go that way or come down, right? We have to probably use some test points to figure it out. Okay, the next thing it wants us to find, though, are the horizontal asymptotes. And we have 3 different cases. This case is going to be where the degree of the top is equal to the degree of the bottom, like I was talking about in the intro there. And when you have the degree of the top is equal to the degree of the bottom, got ahead of myself there, we're going to just say y equals 2 over, this is a 1, right? The leading coefficients of those 2 tops and bottoms, all right? So I'm going to say y equals 2 over 1, or just y equals 2. So that is the line right here at 2, like this. And that's a horizontal asymptote. Now, if it has a horizontal asymptote, it will not have a slant asymptote. So we do have to write something here, so we're just going to write the word none. All right, don't write 0. That's can mean somewhere on the graph, so just write the word none. And then the domain, again, we haven't graphed it yet, but we can figure out the domain because this is a function. We know it has to do something except for at these 2 vertical asymptotes. And so if you think that a normal domain is from -infinity to +infinity without those 2 asymptotes there, right, from -infinity to +infinity, that's just our x values, that's what domain means, it would get broken up at those different points. So here it'd go from -infinity, and then it's broken up first at -3, right? That's where it stops, because we don't have a domain at that spot. So -3, and then I'm going to union it with the other side of -3, okay, until my next spot where I get broken up at, which is +3. Oops, it's a terrible 3. +3, there we go. And then union with the other side of +3, and then I can finally go on to +infinity, like this. All right, so one way to think of it, this is how I tell my students, is that when you have these vertical asymptotes, that's like your unions, all right? So we're kind of starting with +infinity and -infinity, or negative to positive in this case, left to right. But I'm going to get broken up at these 2 different vertical asymptotes, all right? So we have one chunk, the middle chunk, and then the third chunk with those 2 breakups in the middle. Now, we still haven't graphed this thing yet, all right? So this is going to be my domain, right? That's good. But I need to figure out where the lines are going to go on here so that we can get a good idea of what this graph looks like. And that's where you might want to grab a calculator, all right, if you have one. If not, your teacher might want you to do this by hand, which could be a little rough. But anyway, we just need to pick some different points. I like to start with the easiest point, which is 0. If I plug in 0, in fact, this one you probably don't need to use a calculator. This is going to be turned to 0, 0, then we're going to have minus 20 over the bottom here. This would be 0 and then a negative 9. So negative 20 over negative 10 would be a positive 2. So this is going to be positive a little bit bigger than 2. And in fact, negative 20 divided by negative 9. Yeah, it's positive 2.2. So we're going to be up here in this region. Now this is really telling for a couple different things. First off, it tells me that since these are asymptotes, right, you can cross in the middle. That's okay. You don't have to necessarily not cross these. The other ones are a little bit of a different story on the outsides. However, you're going to start probably close to this one is what it's looking like to me. Right, you're going to cut through here and then do something where you maybe probably shift up like that. All right, and then what you need to do is find a point on either side of the other asymptote. So this one over here, if you think about this, this is at negative 3. So I might use like negative 4, probably the next easiest number to use. So I'm going to plug that into my equation. This time I do probably want to plug it into the calculator just to make sure I do this accurately. So I'm plugging in negative 4. Every time I see an x, I'm leaving like an open parentheses for a space there. All right, 2 times negative 4 squared minus 3 times negative 4 minus 20. All right, so on the top there, I would get 24. Again, a little side note here. Positive 24 on the bottom. Negative 4 squared should be 16 minus 9. Probably could do that in our head, but throw it in here and get 7, okay? So we get 24 over 7. Now, again, you can do a little mental math and figure out what that is, or just, let's see, 24 divided by 7 is 3.4. So over here, what this tells me, if it's positive 3, is at negative 4, I'm up 3. So this is 1, 2, 3.4 something. Now, the only thing that our graph can do here, I know there's some words in the way, or some numbers, but the only thing it can really do is get close to this asymptote, right? Go up through my points and get close to the other one. That is it. All right, there's nothing else. Those asymptotes restrict it otherwise until it kind of going below it or above it because it is on the end here. Right now, little caveat, there are some where this out here, it might cross, like to exaggerate that a little bit. It could cross, but then it might come back closer. So I don't know. I don't get too worried about that if my students don't know if it crosses or not. But this is how I would grab. So I want to see that I have this kind of a shape and that they have the correct asymptotes. That's really all I'm looking for on a test or quiz. All right, over here we need to see if it's in this region or this region. And really, I don't have to because I know it's going to cross my x-axis there. So again, I'm kind of restricted to it being close out here, right? Dipping down through my point and then getting close to the other asymptote down that way. Again, that's the only thing it could do. I suppose it could come up again and get close eventually to this asymptote, but that's what we're looking for with this one. Okay, let's try another one. All right, the next one we're gonna do is 5 over x squared minus 4. And in this one, same thing as the first one. To find the x-intercepts, we have to take the zeros at the top. But if I set 5 equal to 0, does that even make sense? No, that is a false statement. So because of that, there are none, right? There are gonna be no times where this crosses the x-axis. All right, so if I have a graph over here that looks like this, my x and y, at no time will it ever cross the x-axis. So it's either going to all be below, all be above, all be below, or have kind of different parts of each. So let's see what would happen with that. All right, the vertical asymptotes, that's going to be the zeros of the denominator. And here again, this is a difference of squares. X squared minus 4 is going to equal, if I set this equal to 0, x equals positive 2 and x equals a negative 2. So if I go back 2, we're going to have vertical asymptotes here, and then forward 2, and here. Not the most even graph, but you get the idea. Okay, and then the next thing it wants is our horizontal asymptotes. This is one where if the degree is bigger in the denominator, we're going to say that it's the line y equals 0. All right, that is true anytime that you have the denominator with a bigger degree. And so to indicate that, we'll draw some dotted lines across y equals 0 like this. Okay, so now I have kind of 6 regions, 1, 2, 3, 4, 5, and 6. And because this is a function, right, it has to pass a vertical line test, I can either have it up here or down here, not both. Same thing, up here or down there, and then up here or down there. It has to be in one of each of those, but it can't be both top and the bottom, because again, it's a function. And also because we know it's never going to hit our x-axis. So, as I mentioned in the last one, since it has a horizontal, it will not have a slant. So that is gearing up for maybe number 3, if you're looking ahead. The domain, however, our domain from negative infinity to positive infinity is broken up at -2 and +2. So again, if I break that up, it'd be from negative infinity until -2, right? Union with the other side of -2 until +2. So from -2 to +2, union with the other side of +2, and then it can go on to positive infinity, like this. So kind of 3 chunks of your graph. By the way, if your teacher has you do set notation, it's been a while. Let me see if I can try it, but I think it's going to be all the x's such that x does not equal plus or minus 2. All right, and then it'd be the set of all the x's to do that. So some of your teachers might like that notation better. In my class, I've been using interval notation. So same idea. All right, then we have to actually graph this thing. So that's where you might want to grab, for me, a different marker, and for you, a calculator. Okay. Again, I'll start with 0. That's probably our easiest number to plug in. If I plug in 0, I'd have 5 over a -4, which in our case, all we need to know is that that is negative, right? If you want to know that's -1.2, you could, and it'd be just a little bit lower here. And again, the only thing this can do is start down low, come up and touch, and then go back down, right? We know it's not going to cross the x-axis here because, again, there are no x-intercepts. So that's the only thing that my graph can do there in the middle. Again, it can't be up here because it is a function, right? What about on this side? If you remember, this is -2. So what if I check out -3? If I plug in a -3, this would be 5 over, well, -3 squared. If you want to use a calculator, you can. It's going to be 9. 9 minus 4 is 5. So 5 over 5, of course, is a +1. And that's going to be above our x-axis because it is positive. And so I have kind of an L-looking shape, or I guess a J-looking shape this way. Touch it and go up this way. Right? And then if you think on this side at +3, is my graph going to do the same thing? Yes, it is, because whether I plug in a -3 or a +3, that's getting squared. And so I'd end up with either way 9 minus 4 or 5 on the bottom. So again, that'd be up here at a +1. Oops, I think I put my dash, my asymptote last time. It should be here on my axis. Okay, so it's going to come, if I get that a little bit closer, start close to your asymptote, come down through your dot, and then get close to this one. Oops, yours probably doesn't have a random bump in it, but come down close and then just keep getting closer and closer, kind of that L-type shape. All right, let's try the last one, number 3. All right, our last one says x squared plus 4x plus 4 all over x plus 1. And this is one where the degree is going to be bigger on the top. We'll get to that when we talk about the horizontal asymptotes. But first off, we do need the x-intercepts. Okay, so this is one where, let's see, we can probably do this one in our head. It's going to be x plus 2, I think. X plus 2 times x plus 2. If I set both those equal to 0, of course, I'm just going to get one answer, which is x equals a -2. I'll put it up here, I guess. X equals a -2. So it's going to cross my x-axis only once at -2, right there. Okay. My vertical asymptotes, however, this is where I can set the denominator equal to 0 and solve. And so for this one, if I set that equal to 0, I'm going to get x equals a -1 if I subtract the 1 over. So an x equals a -1 is here, which means that is my vertical asymptote. I like to indicate that with a dashed line like that, a vertical dashed line. The horizontal asymptote, right, because the top has a larger degree than the bottom, or the numerator than the denominator, however you want to look at that, that means that there's going to be no horizontal asymptote. And when there is no horizontal asymptote, you have to check for a slant asymptote. And you check for a slant asymptote by using synthetic division, which we learned in our last chapter. Hopefully you did as well if you're not one of my students. And so if I take the top here, and I think how synthetic division works. So I'm going to have a 1, a 4, a 4, the coefficients of each term. 1, 4, and 4. And then, remember when I set this equal to 0 and solved, I got a -1. That's what we're going to be dividing by. So that -1 is going to be on the outside. All right, if I bring down my 1, that's going to give me a 1 here. 1 times the -1 is a -1. 4 minus 1 is 3. 3 times -1 is -3, and then this gives me a 1. And then what I think is one of the weirdest things in all of math is that our remainder cancels out. You do not use it. All that you use when you are using a slant asymptote is your constant term and your linear term, right? And this becomes the line y equals 1x or x plus 3, right? I don't know why you don't use that. If you know, maybe comment down below, but I have no clue. So I should probably look that up. Y equals x plus 3 is going to be the line where we start at +3 on our y-axis, excuse me. 1, 2, 3 would go through here. And then this has a slope of 1. So I'd be going up 1 and over 1, up 1 over 1 each time, or down 1 and back 1, down 1 and back 1. So you got to be a little careful here. Down 1, back 1, because it's going to cross on the top part of this dot, like that. Okay, and this is still an asymptote, so I'm going to also use a dotted line to kind of go like this. Now, if you have graph paper, yours is going to be a little bit more accurate. I had to be a little careful here. I do know this dot is going to be kind of in that lower left region. If you think of this as 1, 2, 3, 4 different regions, it is in the lower left one. All right, but anyway, the slant asymptote we can say is that line that we found, y equals x plus 3. You do have to remember how to graph a line. That's maybe the hard part for you. The domain for this, we're still going to have something either above or below, like we did in that last one. So it's going to be from -infinity until this vertical asymptote at -1. So from -infinity until -1, union with the other side of -1, and then it can go on to +infinity over there. Okay, so then I just have to figure out kind of where this graph is going to be located, and the dot that I have on my x-axis is going to tell me that it for sure is going to be in this spot. All right, another thing is, this is a little bit more advanced, but when you have double factors like this, that means it's going to come and bounce off your axis here, okay? It won't go through and come back. And you can also recognize that because since that's the only one, the only thing that this thing could do is come, touch it, and then go right back down. All right, because if it was going to go through, it'd have to come out at a different point, and I would have 2 different x-intercepts, and I don't. I just have the one, and so that's why it bounces off. That's the graphene reason why this works. I don't know how to say that. All right, over here on this side, usually, not always, but usually it's going to be in the opposite kind of quadrant, if you will. But we do need to probably check that again, since 0 lies in either the top or the bottom here. We can put in 0 as a test point and solve. So if I think about what 0 would do, that would turn to 0, 0, and I'd have a 4. Right on the bottom, 0 plus 1 is just 1. So I'd end up with a +4, which, yes, is up there at 1, 2, 3, 4. So again, I don't quite know how it would do it. It might come down a little bit lower and go up. Again, most teachers don't care a whole lot. They just want to see if your graph is up there. And then you go along that other asymptote forever to the right. Okay, so that is how you graph rational functions. Kind of a longer video there with 3 different examples. Hopefully you just watched the type that you needed. One where your degree was bigger on top or compared to the bottom, or vice versa, or maybe the one where they were equal. All right, so until next time, keep doing your math fast and accurately.